In this question, we're asked to give the AX description of xenon tetrafluoride. So the AX is the number of molecules or ligands that are bonded. And the E is the number of lone pairs. So this is something we would find anyway. You may not have written it in this AXE notation, but this is essentially something we would find anyway if we were going to try to determine the shape of this thing. So in order to determine the shape, or to determine the molecules bonded and the lone pairs, we do need to draw the Lewis structure. And if we want to draw the Lewis structure, our first job is to count the valence electrons. So this is a remarkable compound, xenon tetrafluoride, because it has xenon, a noble gas. However, fluorine is extremely reactive, so this is one of the first isolated noble gas compounds. Anyway, we have 8 electrons from xenon, plus 4 times 7 electrons from the 4 fluorines, which gives us a total of 36 electrons. Fluorine's the most electronegative atom, so clearly xenon is less electronegative, so we put it in the middle, and we bond our 4 fluorines like so. Now if I fill the octets of each of the 4 fluorines, that is 4 fluorines, with 8 electrons apiece, for a total of 32 electrons as I fill them in here. That's just a good trick for counting. Saves me having to count the individual electrons. So now I've used 4 times 8, which is 32 electrons. If I have 36 electrons, that means I have 4 more. Xenon already has an octet, fluorine already has an octet. Fluorine can't expand its octet, it's too small. But xenon can. Therefore, we're going to add the 2 lone pairs, the 4 additional electrons, to xenon. To check to see if that's a good idea, what we want to do is count the formal charges. It says minimize the formal charges, but we're essentially going to count the formal charges. So fluorine wants to have 7 electrons around it. Count the dots as 1, count the dashes as 1. So 1, 2, 3, 4, 5, 6, 7. If fluorine wants 7 electrons and has 7 electrons, it's neutral. So this fluorine has a 0 formal charge. All the other fluorines are the same. For xenon, it wants to have 8 electrons, and this xenon has, again, count the dots as 1, count the dashes as 1. 1, 2, 3, 4, 5, 6, 7, 8. Wants 8, has 8. Therefore, this is also neutral. This is a good Lewis structure. As far as this AXE notation, A just stays the same. X is the number of atoms bonded to the central atom. They use in this, Alex uses the terminology ligands. So here it's just the number of atoms bonded, 1, 2, 3, 4. So X is 4. And E is the number of lone pairs on the central atom, 1, 2. This gives us 6 total domains, the 4 atoms and the 2 lone pairs. So this is essentially 6 domains, 2 lone pairs. This actually comes out to be square planar, even though it's not asked here for the electron geometry. Excuse me, for the molecular geometry. The molecular geometry is square planar.